Okay, everybody, here we have our second part of our Algebra Trig number 1 booklet. So it'll help you finish the last details and get you moving. We've got three topics to cover. We'll talk a little bit about harder algebra. I mean, the algebra can get quite elaborate. We can add trigonometry to any algebra problem that we know. So if you have algebra with logarithms, we can stick in trigonometry. Quadratic equations, absolute values, square roots, exponentials, whatever. I mean, we can plug in trigonometry, embed it into any kind of equation, and manage it. And so that'll be some of the questions that you'll see in the trigonometry booklet number 2. But we'll just kind of move it along a little bit so that you can handle kind of general, normal algebra with trigonometry involved. We'll also look at something called impossible triangles, and there are sometimes you're going to get questions that you just won't be able to solve. And we'll look at why, and one of the reasons why. There's many reasons why, and it's quite theoretical if you get into it, but we'll just look at the basic theory on that. And then we'll look at the 3 bizarro cousins. Remember I was talking about the bizarro cousins of sine, cosine, and tangent? Well, they're called secant, cosecant, and cotangent. And if you look for them on your calculator, pretty much no calculator carries them. And we'll find a little workaround. It's very simple, and we'll talk a little bit about how to manage those. Okay, so yeah, we'll start off with some harder algebra questions, and we'll go from there. Okay, so here's kind of the level of difficulty for the booklet looks like this. Maybe just a slight bit easier than the higher level questions before we get into the bizarro trig ratios. So for now, right, 5 tan theta plus 1 is equal to 2 tan theta plus 5. We can think of it just like a regular algebra equation. Tan theta is kind of like your variable x. In fact, some of the solution styles that we give you in booklet number 2 requires you to sub in and sub out, just like you did with logarithms and in our probability unit. But you can sub out tangent for x, and you just solve regularly. Now, you can solve it with x and then resub tangent back in, but I'm not going to do that, not here. It shouldn't be too bad. You just consider them like terms. So after canceling out the 2 tan theta and then the 1, you've got your answers. You've moved the variables to one side and the numbers to the other, just like you would with regular algebra. And now I have to divide off the 3, just like you would with regular algebra. So divide off the 3, and you get tan theta is equal to 4 thirds, or if you convert that to the decimal, you got 1.3 repeating. And now we have to isolate theta by canceling out tangent, right? Inverse tangent to both sides. So I wind up getting a reference angle. Remember, your calculator produces reference angles. I get a reference angle of 53 degrees. And then, as with all trig, we have to go to the cast rule. So let's see how that goes. Alright, when contemplating the cast rule, it's like, well, where do I think about it if it's positive or negative? You go to the point just before you went to your calculator. So in this case, this line over here, right? I had tangent theta is equal to positive 4 thirds, right? Positive 1.3 repeating. So that means tangent was positive right before I went to my calculator. Remember, when it's negative, you have to turn it to positive and use your calculator. We'll look at a negative example again next, but here tangent is positive, so where in the cast rule over here is tangent positive? Well, in all A and T, tangent positive. And we draw on our reference angles. Okay, so we have our 2 reference angles in quadrant A and quadrant T, and we know reference angles go to the closest x-axis. That's the horizontal. One goes to the positive. That's the one in A. That's your principal angle. Anything in A is always your principal angle too. So you got 53 degrees. Boom. Plug that into your calculator. You'll see you get something very close to 1.3 repeating. And then in quadrant 3, in zone T there, I got 53 degrees, and that's past the flat axis, so it's past 180 degrees. And that is, well, you've got the calculation down there. 180 plus 53 is 233. Right, so those are the 2 angles. You can plug those into your calculator, and you'll see they come out very close to 1.3 repeating. And don't forget your coterminal expression at the bottom, plus 360n NEI. Okay, so for every question that you do from here on in, folks, you'll have 2 angles for each question, plus all your coterminals. So just get used to it. You know, it's going to be 2 answers. And some of them won't even be the ones that pop up on your calculator because of whether it's positive or negative. Let's have another look at a question that's a little bit harder. Okay, so here's another question. It's a little bit harder. It winds up having to deal with negative numbers again. So 7 cos theta plus 3 is equal to 2 cos theta minus 1. So let's see how the solution works. Okay, so I'm just minusing 2 cos theta from one side to the other, just regular algebra, moving things around, getting the cos thetas on one side and the numbers on the other side. Right, so I get 5 cos theta is equal to negative 4, divide off the 5, right, reference angle is cos to the negative 1, a positive 5 over 4. Remember, whenever it's negative, you keep it positive for your calculator because that's how your calculator needs to work in order to give you a good reference angle. Okay, so let's calculate that out on our calculators. Go get your calculators, please, go get your calculators, go get your calculators. Okay, so I got a theta reference of 37 degrees. Okay, now we have to go to the cast rule. Remember that when we figure out the cast rule, whether it's positive or negative, you look at the question right before you went to your calculator. In this case, cosine was negative. So we got to think about cast rule, negative cos, and which zones those are in. Right, so cosine is negative in S and T, right? Sine is positive and tangent is positive. Cos is negative in those 2 regions. Cos is positive in the A and the C. So we got to go where cos is negative, so S and T. We draw our reference angles, we find our principal angles. See if you can do it. Okay, so in quadrant S, I'm 37 degrees short of 180, right? That's what that calculation here talks about, right? 180 minus 37 is 143. And in the second zone, I'm past 180 by the same reference angle, so 180 plus 37 is 217. And then don't forget, plus 360n NEI, okay? All right. Okay, so if I ask you to solve the equation sine theta is equal to 5 over 4, we get something called an impossible triangle. And it has to do with the way sine, cosine, and tangent are written now that we kind of gone away from SOHCAHTOA. If you recall over here, right, we have sine is y over r, cos is x over r, and tangent is y over x. So remember that the r constitutes the hypotenuse of the triangle, the longest side of the triangle, right? A right angle triangle, the longest side is the radius, or in this case the hypotenuse. So over here, right, we've got the 5 representing our y value and the 4 representing our r value. That means that this side is a 4 and this side is a 5. That's no good. It's no good because the radius is smaller than one of the other sides of the triangle, and that's an impossible triangle. So there's a detail here that if you wind up getting a sine or a cosine, because remember cosines have r's in them too, that are bigger than 1, those are impossible, right? Because they are, if it's bigger than 1, the numerator, the top number, is bigger than the bottom number, so one of the sides is bigger than the radius, and you can't have that. So that's one way to tell when you have an impossible triangle, right? If the sine or cosine is bigger than 1. We'll look at this again when we talk about wave theory and how that plays out. So it's impossible. Well, that's not exactly true. If you know imaginary numbers, complex numbers, you can solve for that. But that's not really something that we teach you in this class. I know we did a little bit of it in grade 11 if you had me. So for right now, we'll say there's no real solution. That's probably the best answer for that. I'm not going to, I think there's only 1 or maybe 2 questions in the entire booklets that do that because it's kind of trivial, really. I mean, so, oh, you notice that it's bigger than 1? Okay. You might want to ask yourself, well, what about tangent? Well, if you look over here, tangent doesn't have an r value in the fraction, right? Tangent is y over x. And so there's no radius, there's no hypotenuse involved at all, so you can have bigger or smaller than 1 with tangent. You just can't have it with sine or cosine. Okay, so that's the impossible triangles, that's pretty quick. Let's have a look at the bizarro cousins of sine, cosine, and tangent. They're called secant, cosecant, and cotangent. And if you look on your calculator, you won't find them there because the workaround is very simple. So secant, cosecant, and cotangents are your reciprocals of cosine, sine, and tangent. So they're defined in a particular way to help you figure out how to remember them, and then we'll look at some questions where you got to do the algebra. Okay, so secant is the relative of cosine. Secant is the reciprocal, so secant is 1 over cosine, so also cosine is 1 over secant. Cosecant, the middle one, CSC, so we shorten it, is 1 over sine. So sine is also 1 over cosecant. And cotangent is 1 over tangent. So I remember having a devil of a time getting to match these up. I could never figure it out properly. I was always getting them wrong. And then my teacher told me, okay, well, here's how you remember it. And then ever since that, it's been super easy. So each group, right over here, is cosine and secant. Each grouping has a co in each grouping. So secant has no co in it, right? There's no co in secant, but there's a co in cosine. So secant matches up with cosine, right? There's the co. Cosecant, there's the co there, and plane sine. So plane sine there's no co in it, so it's got to match up to the one that has the co. So that's cosecant, and there's the co there. And of course cotangent, well, that's the easy one, right? But so when you're going through this, if you just make that as part of your memory, it's something very simple, a nice easy way to remember it. You're dealing with the co and it's plane secant. So cosine, plane secant. Sine and cosecant. Remember it that way, it's easy peasy. Let's have a look at some algebra. Alright, so 5 secant theta minus 4 is equal to 2 secant theta plus 3. And this can be the same for cosecant, cotangent, it all works the same way, so I'm just choosing secant. And, okay, so let's play this out. I'll drop a little t-chart for you. Okay, so my first job really is to isolate secant theta. And so I have to, do the regular algebra that you've been seeing all the way along. And then, you've got to, divide off the 3 as your last step here, so I'll show you that. Okay, so there's secant theta is equal to 2.3. Now I've kind of gone further than I need to. If I just leave the answer as a fraction as 7 over 3, I make my life a lot simpler. Let's have a look at the next step. Okay, so next job is to convert secant to its, something that we can actually do on our calculator. So you have to make it into a cosine. Remember, secant is 1 over cosine. So we rewrite out secant as 1 over cosine, and it's much easier leaving it as a fraction because I have to be able to flip both fractions in order to access cosine theta, and that's the next step. So going all the way to the decimal typically is how you manage, but when you're dealing with secants and cosecants, you wait until you've flipped both fractions. Okay, so now you flip both fractions, cosine is on the top, and it's 3 over 7 instead of 7 over 3. You get 0.43, and now it's easy peasy, just like from the stuff that you've been doing before. So let's see if you can solve it, and I'll put up the answer right now. Okay, so I got to go to the cast rule, get my reference angle. I did my reference angle of 65 degrees. Cast rule, I'm in quadrants A and C, so quadrants 1 and 4. And I do my calculations. Principal 1 is in the first quadrant, so 65, that's over here. And then number 2, I'm 65 away from 360, so 360 minus 65. So what's that, 295? And then don't forget your coterminal expression. Now this is another way to write your coterminal expression. You can use plus or minus 360n, where n is an element of the whole numbers. So whole numbers count only positive. So integers count negative, and I'll quickly show you the difference between the two. Okay, so you can write them like this, 65 degrees and 295 degrees plus 360n NEI, or plus or minus 360n NEW. There's less symbols for the top one because you have an extra minus symbol that you have to sort out. And the difference is whether you're talking about integers or whole numbers. So integers, right, if you recall from number theory way back in grade 10, I suppose, is integers are negative and positive whole numbers, right? Negative 25 is an integer, negative 14 is an integer, 38 is an integer. 29.7, that's not an integer because it's got a point in it. So they're positive and negative whole numbers. Where whole numbers are start at 0 and count up, so it only counts the positive. So if you're going to use whole numbers, W, as your element of, then you have to make sure that you include the negative sign in there. So these are really the two main ways people write them. I don't care which way you write them. There are other ways too, but these are typically the two most common ways to manage that. All right, let's have a look at some of the questions in your booklet. All right, so page 1 really talks about whether sine, figuring out how the Calc rule works. Is sine positive or negative in the particular regions? And so the first section says, okay, well, question number 1, match the quadrants where the following trig ratios are positive or negative. So it says, question number 1, sine theta is greater than 0, so sine theta is positive. Which regions is sine theta greater than 0 or positive? Well, that's in A and S, so that would be quadrant 1 and 2. So you gotta go find quadrant 1 and 2. I think that's letter D, and so number 1 matches up with letter D. In the second section, I changed from being sines, cosines, and tangents to y's over r's and x's over r's, right? I know it's hard to see it off the screen. So all you have to do is just remember the ratios of sine, cosine, and tangent as how they relate to y over r. So where is y over r greater than 0? Well, recall sine theta is y over r. So you just convert it from y over r to sine theta. I change it, and then that's just like the last question, right? So same idea, right? Quadrants 1 and 2. And that's all I'm really asking you to worry about there. So the third one says, okay, section 3 says, where would I find 2 sine theta is equal to, is it negative 1? No, it's positive 1. Positive 1. So where would I find 2 sine theta is equal to positive 1? Well, you just have to do a little bit of algebra. Divide both sides by 2 and see whether you get a positive or negative sine theta. You divide both sides by 2, you get sine theta is equal to positive a half. So which regions is sine positive? Again, in A and S, which is quadrant 1 and 2. So that's really what that is. And then on the bottom, I get you to draw the coterminal arms. That's pretty much the first page. Okay, so 2 sine theta is equal to 1. And then, so this is on section 1, page 2. And so it's just a matter of calculating out your reference angles. That's using your calculator, watching out for positives, and then watching out for negatives. And then in section 2, okay, you use the reference angle from section 1, and you apply it to the Calc rule, and then you find your 2 angles. So section 1, reference angle is 30 degrees. What's that? Letter D. Yeah, so section 2 is just completing the job, right? You got the reference angle from the section above it. In section 2, same question. So now it's just applying the Calc rule. It's similar for the next 2 sections after that. You've got, only this time you're dealing with negative values. So be careful on your calculator. Don't plug in negatives, inverse, like sine inverse of negative 0.5 or whatever, because it's just going to mess things up. And I mean, I don't want to teach you 3 different methods to solve the same problem. I showed you that one time. You keep it positive for your calculator, and then you just work from the Calc rule afterwards. Okay, so that's that. Okay, so page 3 just talks about some of the theory. You got some true-false questions in there. You got some critical thinking that asks you to deal with, some of the impossible triangle details we talked about earlier. And then we start getting into the actual solving of questions, right? So, we're starting off with some rather simple equations down here at the bottom. And that carries you through pretty much to the end of the booklet. Right, the next page after that is the same. Oops. It's setting you up for the equations, and then you get your reference angle and your principal angles. Don't forget your coterminal statements. I'm going to be looking for them when you hand it in. And the last page deals with secants and cosecants and cotangents. So hopefully you'll remember how those play out. Remember the co-relationship, so secant and cosine. cosecant, and sine, right? So don't forget how those work. If you need to check with the video, then go back to those spots and see if you can play, sort those details out. And as always, I try to do my best to provide you with the key, right? The key should also be attached to that particular booklet, so it can help guide your learning and help you sort out those details. Don't use it as to answer the questions. No, don't do it. All right, so I'll talk to you guys later. Bye for now.